हेलो। पीडीएफ शेयर करता त्याच पद्धतीने आणि मॅक्सिमाइज करता कंट्रोल एल घेऊन नाही होत का? Hey guys, good evening. Good evening. We are just trying to assemble over here. We are waiting for more people to join us. So let's give about 5 to 10 minutes more, so that then more professionals can join us both online as well as over here for the live session. If there is anything, feel free to just unmute yourself and ask me the question. We'll just mute this at this end for the time being before we are able to start. So just let's give about 5 more minutes for more people to join us. Thanks. Hey guys, those who have joined us online, we are just waiting for about 5 minutes. We are hoping to have some more crowd over here. Once we have a few more people join us, we'll immediately start. Give us another 5 minutes. Hey guys who have joined us online, we are just waiting for a minute now and we should be starting pretty soon. So please hold on. Thanks for your patience and we should be starting soon. Just give me a minute or two.
Testing.
Naidu, can you hear me?
Good.
Hello? Naidu? Hmm? उसको जानबूझ के वहाँ पे बिठाएं। Okay. So good evening, everybody. Thanks for joining us for this session today. We had some very interesting discussion earlier in the afternoon with Pradeep about his startup, how they started off, and how they ended up being where they are today, being number 2 startup company in the clean tech space amongst top 10 ranked in India, which is fabulous, I think. So congratulations to you for that. I would just like to quickly touch upon IC, what we are trying to do. Institute of Civil Engineers of the UK. The Mumbai Association is been active for the last 3 years or so. We are trying to conduct multiple touch points, multiple events for our members, for the benefit of not only our members but fraternity at large. We are connected with multiple consulting houses and construction houses within Mumbai, and we do these kind of conferences. We provide support for professionals who are actually interested to pursue being professionally registered with the ECUK, being chartered or being fellows as well with the Institute of Civil Engineers. So happy to provide any support, any connection needed in actually helping you become professionally certified or become fellows as well going forward. I'm quite happy to share that we, as IC, have been, especially the Mumbai Association, has been successful in getting a lot of support from IC, especially from a professional registration point of view. We have been conducting the professional reviews itself in Black and Beach right over here in Mumbai. So professionals who are based out of Mumbai region and aspire to become professionally certified, professionally chartered, they have an opportunity to really be a part of this group and explore their career advancement, career development further through the IC. With that brief introduction to IC, I will hand over the platform to Pradeep to take us through his fantastic presentation. I'm very sure it will be an extension to whatever we heard from him so far in the afternoon, and I'm hoping to learn more from this one. So thanks a lot, and we'll hear from Pradeep. Over to you, Pradeep. Yeah, thanks.
Thank you, Rakesh. So the presentation in the afternoon was, as you had requested, was more about how our journey was through the different pivots that we went through and how we reached where we have reached. Right now, in this current presentation, I'll be focusing on the technological developments which we did till now, more specifically what we are doing right now, and how we enable a new ecosystem which was not feasible till now. So this slide briefly shows what we do. This is to a large extent common sense in the biogas scene, that every biogas plant makes biogas and sludge can be used to enhance soil, and biogas can be used for cooking or any other purpose, similar purpose. Now, in spite of more than half a century of government push, biogas plants in India never took off. And the reason is that they are not financially viable. They are not financially viable. A biogas plant is a chemical reactor and need the care of a chemical reactor. I mean, the pH has to be maintained, the microbial levels have to be maintained, everything. So when you set up very small biogas digesters, more often than not, it's very difficult to operate them in the optimum conditions, and then they stop. Once they stop, the incentive to keep them running is very low, so people don't run them. And typically individually owned uh, digesters are, in many cases, the expertise is not available to keep them running. So the ideal way to run them is to run them professionally, and all professional biogas plants, to the best of my knowledge, are running fine, right? Because you have a huge set of engineers ensuring that all the conditions are maintained properly. Interestingly, these big plants suffer a big problem. So all the biogas potential in India should have then been reached with people setting up big commercial biogas plants, but that did not occur either. And that's because carrying the waste to the centralized biogas plants is economically unviable. So you have a big centralized biogas plants only when there is a very sustained availability of waste close by, right? So the that's the catch. So how do you solve this problem? So this is where we bring in our expertise. We have decentralized community scale. We call it community scale just to give a perspective. That's between 100 meter cube per day to 400 meter cube per day. That's the size of digesters which we install. So that's a community scale plant, which is much smaller than what a utility scale plant would be, 1,000 to 10,000 at the very least, 1,000 to 10,000 meter cube per day, and much bigger than what a domestic plant would be, a 5 meter cube plant per day. At this scale, uh, it becomes feasible to collect waste from close by areas and run the plant without a real risk of logistics, right? But the problem is that the slurry, which is the output from the digester, and the gas, typically community based biogas plants supply gas to the community, to the local community. So you're locked to the community. If the community doesn't take the gas, or if the community feels that the gas is available at very low cost, should be made available at low cost, because domestic LPG is made available at a low cost, you have to make it available at a low cost. You cannot go and sell the biogas in another market where people are willing to pay you more. And so the economics of the plant is very closely locked to its geography. Same is true for the sludge. The sludge is not transportable. You cannot transport it over 100 kilometers. So these two are major issues. The generation and the sales are geographically locked. So if there is one thing I would say, the biggest innovation which we brought in is we have decoupled it. We have made the output of a biogas plant transportable. So I'll first touch upon the compost part, and then we will speak about the biogas plant. Next one, please. So this is basically what I spoke about. Uh, the bio-CNG potential in India is untapped because of precisely the reason I mentioned. Because it's unviable to transport low-cost feedstock to a large centralized plant, which can reliably convert it into biogas. Next one, please. So we bring in a disruptive system which actually can work at scale as small as 100 meter cube per day, profitable, is economically viable. So that and VOV, the capex is 1/4 of the industry standard cost, and obviously it's distributed. Now you can set it up close to the point of waste generation.
When you say 1/4 of the industry cost, it's primarily based on the calculations for
Small size. So if I divide, if 1,000 meter cube plant is available for say X, then I'll convert it to a 100 meter cube plant by saying X divided by 10, and now I'll compare it to the cost which I get. So that cost. Yeah. 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 Because they don't scale down. So if today you buy it will not be a geometric division by 10. These plants are available at costs which are much higher. So it becomes literally a non-scalable business, because of which they are not commercially viable. Sure. I guess I'll be speaking about the biogas part first, and then I'll come to the compost. Right. So no, please, the last slide. So this is one of the most important innovations which we did in upgrading the biogas. Biogas basically consists of methane and CO2. That's why its calorific value is low. You can somehow get rid of the CO2. You have pure methane, which is natural gas, which can be sold at pretty high price, which goes in our vehicles at 50 rupees per kg at the very least. So that's a good number, right? Now the problem is, how do you get rid of the CO2? Commercially viable technologies exist which operate at above 1000 meter cube per day, and more viable actually above 5000 meter cube per day. So this we have a patented solution which uses rotating discs mass. It's a mass exchanger based on rotating discs, which creates a huge surface area of flowing water, because these discs are hydrophilic. So you have a water surface forming on both sides of the disc, and this huge surface area actually absorbs CO2, because CO2 have good solubility in water. And what we do is do the same thing in atmosphere at the bottom, because CO2 percentage in the atmosphere is negligible. The partial pressure is practically zero. So all the CO2 is released back again because of huge surface area. So the same technology used both in scrubbing and in regeneration of water. And with that we can operate at atmospheric pressure, while most competing technologies operate at a pressure of n bar to 30 bar, because they use something like PSA is one of the technologies which could be used. Pressure swing adsorption. You take gas under high pressure, then the gas would be dissolved in whatever fluid is available. Then I take the fluid to very low pressure, so all the fluid will be released. I do roughly the same thing. The partial pressure inside is 10.1, so 10%. Outside it is practically zero. But with such a small differential in partial pressure, we can operate because of this patented technology. We save a lot of capex right away, opex right away, because rather than operating at 10 bar, we operate at atmospheric pressure. Imagine the cost of the compressor gone, the cost of the electricity to run the compressor gone, right? Next one, please. So these are images of how it works. The first images which you see is the scrubber. The second image is the regenerator. So basically water flows through these channels. This has been opened to show the discs. It's it's airtight, because you don't want the biogas to be locked. And that one is always in the air because we are regenerating. That gives you an idea, a basic sense of how this thing looks. Next one, please. We did not speak about. Yes, CO2 and H2S. Yes. Sure. Yeah. So next one, please. Yeah. So one specific slide which I wanted to mention before I talk about this one, is we also are working on a technology right now to the upgraded gas is typically stored at 200 bar in compressed cylinders. It's compressed and stored at 200 bar. We are working on a technology, an adsorption technology, to achieve it at something in the range of 35 to 50 bar. Rather than compressing, we'll be adsorbing. It's traditionally used in hydrogen storage, but it can also be used in methane storage. We are midway in that, or rather we are almost done in it, but we are still to launch it. One of the reasons why I did not show photographs of the system, but what it would allow us to do is again save on the capex, because 35 bar instead of 200 bar thinner cylinders, and again save on the opex. Same electricity cost of reaching till 35 bar instead of reaching till 200 bar. And a very important thing which it will allow us to do is stay below statutory regulations, which hit at 100 bar. Statutory regulation is a big cost for a plant. So if we want to operate at low cost, we have to, the safety regulations become much more stringent when we touch 100 bar. At 35 bar, the safety regulations are much lower. You need certain safety stuff. I mean, there is a big guideline from PESO. You need to follow A, B, C, D. Again, it's like step-by-step things. You cross 50 bar, you do all this. You cross 100 bar, you do all this. You cross 200 bar with a combustible gas, you do all this. So there would be a lot of sensors, firefighting equipments, etc., etc., and they are needed.
The impact is primarily on the capex
and the opex. Yeah. PESO. So that's one area which we are working on, and we will be pretty soon out with that solution. And this is the third thing which we are doing. Again, this is midway, we have not finished. Rather, this is on the drawing board. Most compressors in the industry today are based on solid piston, like a piston compresses the gas, or a screw which compresses the gas. This is a liquid piston compressor. One of the biggest advantages, since we are dealing with the liquid is more often than not water, and it's a hydraulic pump which just pushes the liquid, and the gas has water in it which needs to be removed. That's a process, that's a stage in my system. It consumes electricity. That will be automatically removed, because when I press water, when I compress the gas, which up to 35 bar, what I'll be doing is, I think you would understand, as we go higher in altitude, the pressure decreases, so water starts to evaporate at lower temperatures. So when we increase the pressure, water start to condense at lower temperatures, which is what it will precisely do. So the dew point would be much higher. The temperature at which water condenses to become liquid from the air will be much higher. So right now we need to reach dew points as low as minus 40 degrees centigrade. That would be very, very much lower in this particular case. And so much more, again, energy efficient, and OPEX, less intensive on OPEX. So all these things together now make it feasible to run a small plant where the electricity costs, the auxiliary overheads are, because typically the auxiliary overheads is what kills this plant, among other things. That's one of the major challenges. Now your auxiliary overheads also go down, right? So your plant can become profitable. So it starts to become economically viable. So please. One of the innovations which we did with our plant was, we had lots of issues generating biogas in winters. We operate in northern part of India. So this is a very simple innovation. We run engines from which operate on biogas. A lot of processes on the field generate a lot of heat. So we designed our own heat exchangers to capture that waste heat, which is now pumped into the digesters. You can see some hot water. Then this is from our site. I couldn't get a better photograph, but this is the hot water that is generated on our site, which we use to feed our digesters, and that helps us to maintain the production of the biogas, which is very critical. Again, although this might seem pretty small, your biogas production could go up by 10 to 40%, or rather it could go down by 10 to 40% in winters, which we do not allow it to go down by adding heat. So, although it might seem small, but you can imagine of the economy, 10 to 40% your one of your products output. So very critical for us. Next one, please. So that heat comes into our digesters. We have also worked on some specific uh, internals, which is, if I may put it, so we don't build these digesters. We just buy them off the shelf. They are plug flow digesters which are available off the shelf. But these digesters are designed for dung. They are not designed for something like agro waste. They cannot design agro waste. Agro waste, stock, paddy stock or maize stock, etc. So this stock needs to be pre-treated. Okay. So we have developed sorry, dung. Cow dung. Not necessarily cow dung, but dung. Any dung. So dung per se. However, by pre-treating the paddy or the other agro waste stock, you can use them in the same digesters. And pre-treating is not a big deal. It's available. It's a decade-old technology. But again, the amount of energy and the capex of the status quo pre-treatment plants make them financially unviable. So we built a biological pre-treatment plant, and which takes a little bit longer, but because we are so small, we don't mind it, and it does it at pretty much zero energy cost, right? And so the OPEX again goes low, and so that's the fourth innovation which we bring in to. It's aerobic. It's aerobic. The pre-treatment. The digestion is always anaerobic. The pre-treatment is aerobic. It's partly aerobic, partly anaerobic. So half of outside the digester, half of it happens inside the digester. So the aerobic part happens outside first, and then there is there is also mechanical part to it. The first one is the mechanical part where we shred it, simple shredding. So to keep the capex low, in fact, we at some of our sites we don't even buy the shredder. We rent the local shredder, which are easily available, and we shred it. So that's we need it to be a little smaller in size, and then that's the mechanical part. Then the first biological part A, and then biological part B. Next one, please. One of the most interesting things is we operate in very rural and peri-urban areas outside the city. However, CNG, its demand is unmet everywhere. People don't drive CNG cars, or you don't have CNG autos in villages, not because they don't want to, but because they don't have CNG. Right? CNG is cheaper than diesel. Everybody would want to drive a CNG if it is available. So, second, all agricultural instruments which you see, almost all use diesel, and the smaller ones use petrol. For example, you would have seen small Honda engines used for sugarcane extraction. They're on petrol. There is a reason why, because it's very difficult to design very small diesel engines. You need to design petrol engines. All of them can be retrofitted to run on gas, much like any petrol car engine is. And so the possibilities are very interesting of what we can achieve by supplying gas in areas where it is traditionally not available. I mean, even today, several major big cities in India don't have access to CNG, compressed natural gas, and I don't see CNG hitting rural markets anytime soon, right? So whatever CNG we generate, we will always be in a market with unmet demand, right? So it's a very interesting thing. It's a very interesting place to be in, having a product in a market where there's an unmet demand. One more thing which we are doing is we are converting some farm equipments to run on CNG. Traditionally run on petrol and are very costly to run because of that. Because petrol is like today 80 rupees per liter. If I were to do a simple calorific value and power based analysis, we'll be saving around 30%, 30 to 40% of the operation cost. Next one, please.
The commercial cooking device that you showed have to be customized for working on CNG, right? The normal
See,
ones that run on LPG will not.
do you have piped natural gas at home?
So for that it should be no.
Why? What is piped natural gas?
It's
It's not CNG.
It's
It's NG without the C. It's natural gas which is not compressed. It's piped. It's at atmospheric pressure. So if I bring this CNG to atmospheric pressure, it becomes natural gas which will run in a normal stove, right? Natural gas at home. No, it won't be. So a compressed gas is not used directly. There will be a reducer. In fact, I did not mention it that since we are building a technology to operate at lower pressure, we have a distinct advantage. Every CNG installation needs a pressure reducer. So you bring the pressure from 200 bar to something like 5 bar to 1 bar. There is a reducer in the line because you will be using the utility only at 1 to 5 bar. So because of Joule-Thomson effect, that reducer experiences very low temperatures and a thermal shock. So then they are very costly. So the Joule-Thomson effect is much lower when you bring it from 35 bar to 5 bar than when you bring it to 200 bar to 5 bar. So they could be much cheaper in our case, where we are trying to achieve it at much lower pressure. Again, that's a huge capex, and that's a very critical capex because one of the biggest issues is who will pay for that reducer. The who will pay for the reducer, whether the end user is paying for the reducer because it is in his premises, or the utility company pays for the reducer. Now when the price is like 70,000, both of them debate. When the price is 5,000, we agree very easily on some number, right? Okay, you pay half of it, I'll pay half of it, and let us agree, right? So I mean, I cannot tell you how critical that is to this business. Bringing down that capex, which is in the client premises and not owned by the client in a sense, and who pays for it. So I think that answers your question. Safety question, because the cylinder is typically outside the premises, the pipeline only will go. To answer your question, at 90% methane, natural gas calorific value is similar to LPG per unit weight. Same gas can be used practically, say, here and there. So the air fuel ratio did not change so drastically. Good? Good? Yeah, next one, please. I spoke about this in detail in afternoon. I would not touch it in much detail now. One of the things, as I mentioned earlier, was we operate in very remote rural areas, peri-urban areas. There you cannot work till you have community engagements. So we have very deep community engagements. We add value to them. We give them a lot of stuff. For example, the dung we collect is on a barter-based system. And the barter is services which are not available in these areas. For example, veterinary services. So their animals, if they fall sick, they never have access to a doctor in villages for their animals. Government doctor is supposed to be available, but typically is overloaded. So we give them that, and as a service, we give them that in lieu of something which we want, which could be done, right? We give them animal feed, very high quality animal feed at a very low cost compared to what is available in the local market, and we have seen pretty high increase in milk production, 10 to 20% increase in milk production. So we create a lot of value for them. They are our stakeholders. They allow us to work in that area. They give us very important raw materials to work in that area. We make sure that we create value for them. We at some of our plants we run RO systems, again using the electricity which we create ourselves. So we supply them with clean drinking water, which is of very good quality. So it makes a lot of sense for them to feel good about us, right? So a study was done by Santa Clara University, one of the most reputed impact space universities, and it's available online. You can read about us. It says that we are creating very important impact with the people we are dealing with. The next one, please. I spoke about it, so that's basically captured in a slide. Next one, please. I wanted to speak about them first, but interestingly, the slides were swapped. So I started in the beginning. One of the biggest innovations which we bring is decoupling the point of generation and the point of sales. Sludge is not transportable, much like biogas is not transportable. By converting it to bio-CNG, we make it transportable. So it need not be sold next to our plant. It could be sold 200 kilometers away, right? And if it is economically viable to transport gas from Qatar to India, it must be viable to transport gas from the site of my generation to 200 kilometers away, right? But it is definitely not economically viable to transport dung from point A to point B in most cases. So the value add is that you take the site to the area where the dung is, not the dung to where the plant is, and that creates all the difference. Transportation of the high value material, high value, high density material rather than low value, low density material. The other plant, the other revenue which is very important for these plants to turn economically viable is the compost. The sludge is not transportable because it is something that you would not like to touch. Most people won't like to touch. What we do is we convert it into solid and liquid components. The solid component is enriched. We enrich it, value add. We add cultures, we add enzymes, we add micronutrients. And we do the same thing with liquid. One of the interesting things which this liquid has is some very active ingredients which are normally overlooked by the fraternity, by the biomass fraternity. But these liquids contain some very important active ingredients which we concentrate and we package and we enrich. And in the end, because of the enrichment, you can see a lot of advantages which come with them. We have done lots of field trials and we have seen some pretty good results. One of the biggest advantage of liquid compost is it's not available in the market today. Liquid compost is not a product. It's something that we launch. One of the biggest advantages, farmers spend a lot of money in labor, in applying in applying the fertilizer to the plant. But since it is liquid, it can go with irrigation. Second thing is, once your plant is standing, solid fertilizer is very difficult to apply. I mean, nobody really applies solid fertilizer once your plant is at its teenage. But again, it is possible with liquid. And it is very important because at that point the plant needs a lot of nutrients. When the plant is at its so-called teenage, it needs a lot of nutrients, much like humans or any other organism would need. But it is not possible to supply at that specific period of time. Liquid nutrients are very easy to absorb, so the plant is able to absorb them very fast, and we can supply them even on a standing crop because you don't need to walk between the crop. You can do something as dumb as flood irrigation by adding this liquid into it. So the next one, please. So we have used it in the field and we have seen some pretty good results. That's our first batch leaving our factory. Yeah.
No, my question was about the slurry.
Uh-huh.
How do you sort of segregate the solid and the liquid out of this process? Like in a wastewater treatment plant, you would have a specific process to make the sludge heavy enough.
Okay, we use a centrifuge. We use a centrifuge to do that.
That's not costly.
It is costly, but then you have to. I mean, so far we have been using it. If we are able to innovate something better, then so far it works. I mean, it sits in the economics. We can live with those costs. So.
When we say about this liquid compost, how do you provide them the controlled quantity? Over compose is also dangerous for the plant. Right?
Yes. Next one, please. Next one, please. So we tell them how much to add. We have a chart for which plant how much to add. If you add more than this, you are responsible. Simple.
But you get a consistent quality of this.
We have it's okay. Consistency is relative, right?
No, but consistency.
No, I'll tell you. Consistency is relative. If I ask someone to add between 10 to 20 liters, if that big error is okay, right, then it's okay if my product lies between that concentration, double to half. So do I get consistent quality of the product? Yes, consistent enough for me to stick to one checklist, one chart. You are minimum, maximum you apply this, you only apply in this range, and my compost will fit somewhere in that range. So what is acceptable, we fit in that range.
Does it depend on the portion of the animal waste to
The agro waste.
waste?
Yes, it depends on a lot of things, and I would like to add one more thing, that we enrich it. So there is a control process at the end of it, which we control. So in cases where we need to enrich it more or we need to enrich it less, we can actually do a run on how much we have got and add something more or add something less. So that allows us some leeway, although it doesn't allow us a lot of leeway, because what is the most important? Else I could have taken water and added the ingredient, right, and still have a product, but it doesn't work that way. That said, in fact, it's not only a function of the ratio, it's also a function of the ratio of what is going in, which agro waste, paddy is going in or maize is going in. So that's something that we optimize. That's something. Interestingly, plants which are grown in any place are very cyclical. So you will first have, I mean, there are 3 plants in a year, and you will have paddy, and then you will have rice, and our supply chain fits in together. So we love to repeat the same thing, because then we don't have to change any other thing in here. So one of the biggest issues which we had sometime in past was the acidity of this was high, because we did not understand that the HRT increases in winters. In winters, the digestion becomes simple, because of lower temperatures. So what you get as compost is not fully digested if you keep the same feeding rate as summers. So something as simple as this, learning something as simple as this. I mean, we all knew it, right? I mean, as an engineer, you know, every chemical reaction slows down at lower temperature. And so whatever is possible in summer is not possible in winter, simply because Bihar goes from 45 degrees centigrade to 12 degrees centigrade in winter. I mean, Bihar is where this plant is. So it is not possible to have the same sort of performance. But how it will impact our something 8 months down the line, we had never thought of. But then it happened, and there is a lot of learning. So this is a survey. It was done by a third party, and we have 87% satisfied customers, over 2,000 farms tested. and we are really happy. And right now we have done better. We are counting Tata Trust among one of our esteemed clients. We are counting ITC is interested in a deal. We have Sydney. We have a lot of FPOs, local FPOs. So last 8 months have been very interesting. They have been seeing our results. They have been doing demonstrations, and uh, we have very positive feedback coming from the field. And I'm very hopeful that by the end of this quarter, that's March, we would have booked orders for almost all our product by probably a B2B customer rather than a B2C customer. Next one, please. Sorry? 87%? Local farmers, all Biharis. I mean, I told you that it's now profitable to transport it, but we're still talking around 1,000 kilometers, not more than that. So we have also, lately we have also supplied to states outside, adjacent to Bihar, but those are not a part of the survey. So the survey was done exclusively in Bihar by a third party. So that's our impact matrix, and it has become slightly outdated, because if you replace any chemical fertilizer with organic fertilizer, it's a huge reduction of greenhouse emission, because around 20% of the total greenhouse emission comes from industries, of which 20% comes from heavy industries, of which a good 50. I'm sorry, I can't recall those numbers. I don't want to say wrong numbers, but it's a big number of what chemical fertilizer as an industry contributes to greenhouse emission. If you reduce chemical fertilizers, it's a fundamentally different story, that you are making your food products more eatable, more nutritious, better from a holistic perspective, but you also save on a lot of greenhouse gases. And plus we collect a lot of methane, which is 25x CO2 potential, and bottle it and then replace commercial LPG, say, in most cases. So even that has a huge greenhouse potential. So what we do has a big number. Of late, we have not been tracking it. We were tracking it till very recently. Of late, we have not been able to track it because our operation suddenly expanded in different areas. But I think I'll soon have some updated matrices, and we can share about how important it is with respect to sustainability. The organic produce definitely helps us to improve the food quality and also reduce costs for our farmers. So their profitability rises. Our activities in the community area help us to improve the productivity of their animals. So as I said, 10 to 20% increase in milk production by using the feed which we give them. So all in all, we impact at least 3 of the UN goals of reducing poverty, food security, and carbon emissions. So that's at least 3. Probably we do more if you were to look subtly, but at least 3 we impact directly. So yeah, next one, please. I'll come to that. Yeah, we are done with it, I guess. The next one is, okay, that's a growth plan. Next one, please. Okay, now I'll answer that question.
So my question is about organic manure, organic fertilizers.
Yes.
Being able to actually increase because organic farming today in India is more expensive to do, and that's why organic products cost more, because especially the scales are
okay. I have answers to all your questions. So if you have still more, I'll give you an answer, and if you have still more questions, go ahead. Organic fertilizer is not equivalent to organic farming, right? So there should be no chemical input, including pesticides, etc. So just by saying organic fertilizer, we are not saying organic farming. Number 1. Number 2, we are replacing. You would have seen in the presentation 60 to 100% reduction in chemical fertilizers. So our farmers have reduced their chemical fertilizers from 60% to 100% in certain cases. Okay. The third thing is, can it give a 20% increase in production? Yes, depending upon the soil. So if your soil is dead, when I say dead, I mean if it does not have carbon, if it does not have any sort of microorganisms, then all the micronutrients which you add to the soil are never absorbed by the plant, because they need to be brought to a stage where they can be absorbed. I'm talking a little bit of agriculture chemistry here, but the point, simple point is that it is possible that for a specific soil, the important ingredients are not available, and chemical fertilizers are do not always give them in a way where they can be taken up by the plants. So although you can keep adding them in the soil, the plants will not take it. For example, even nitrogen, if you add directly, the plant cannot take it till the nitrogen is broken down by microorganisms into a form which the plant can absorb. So if you add organic fertilizers in this case, or compost in this case, in which the nitrogen is in a very readily absorbable form, you will see a 20% growth, because the plant was not taking it earlier, now it's taking it. So if you are giving chemical fertilizer in a very scientific manner, an organic fertilizer cannot beat it. But if you're already killed your soil by applying chemical fertilizer for a long time in a very unscientific manner, then an organic fertilizer will give you great results for the first 5 to 6 years. And even after that, you can replace your chemical fertilizer completely, because the organic fertilizer is capable of supplying everything, right? It is in most cases, at least the enriched ones which we make, except I mean, just to give you a.
So when you say organic, it actually contains NPK component also, right? Or we still need to go for urea and other things.
Is it a combination of?
Yeah.
Okay, so let me give you an example. I cannot answer this question in detail because of issues about what goes into it, but let me give you an example. Nitrogen is one of the most unfortunate nutrients to be supplied to the soil. Nitrogen is everywhere, right? The problem is that nitrogen cannot be absorbed into the soil that fast as you want to. What if it could be? What if the nitrogen which you supply to the plant comes from the atmosphere rather than from urea? Sorry? You don't need to supply it separately. But what, I mean, traditionally nitrogen came from the atmosphere. How? I don't know. It's high school science. We all would have rhizomes, nodules, plant, chickpea, right? And then those rhizomes will leguminous plants can actually fix nitrogen from the atmosphere into the soil. So you should actually have that between two crops, right? Now, but then nobody is willing to do that. People are not willing to wait for 15 days so they burn their stock, right? So you definitely cannot have a different crop in between two paddy stocks. But then there are some organisms which can do it. There are some organisms which can do it even without forming a legume with the plant, say like paddy, because they might have their own plant, like say algae, to form that with. So it's possible not to supply NPK in a packet, but still supply it. Does that answer your question? So do I supply it? I'm not going to say that. So, okay, just to add one more statement, 60 to 100%. It depends on, we replace 60 to 100% of all chemical fertilizers. So I think that answers it. Depending upon the situation, we can replace 60. Depending upon the situation, we can replace 100. Yeah. Any more questions? Any online questions?
One hypothetical question. If I want to just sell your product like liquid compost, the Israel country, they adopted actually irrigation system of sprinkler or maybe laying of pipeline to every plants and dropping of water. So how can we mix that particular liquid compost in the pipeline or maybe sprinkler system, and how can we control that?
What do you want to control?
Compost, liquid compost.
See, this liquid can be applied in all three ways. I showed that image, right? You can sprinkle it, you can use a spray. You can supply it via liquid irrigation.
Talking about control of quantity in the water.
Control of quantity is very simple. What quantity you want? Okay. Since you talked Israel, I'll tell you. They are like really smart people, and you don't need to be really smart to do this. You can decide whatever ratio you want. You can have a very small system where you control the solenoid based on some algorithm, and the liquid will be injected into the water at that rate. So I will control the amount of liquid which goes into it. How much liquid should go, that we have to optimize for that particular crop, for that particular soil. And then it's a in final year BTech project, probably third year BTech project. How do you control the ratio of two liquids? By using two solenoids. You use a microcontroller. You tell me the ratio what you want to control. Open this to this ratio, whatever you can have two valves being set to some ratio where they mix, right? I mean, doing that, I think I'm pretty sure there must be products in the market to do that. I know that liquid nitrogen is available. Nitrogen is available in liquid form. So compounds dissolved in water which supply nitrogen to the plant. So there must be some mechanism already available commercially. But even if it's not available, it's a very simple thing to build.
So, I mean, if you have any questions online, please unmute yourself and ask the question. Do we have any more questions from anybody over here, in addition to whatever we have already been asking so far? Any addition? Gayatri?
Apart from the rural, the utility value in the rural market, uh, what could be the other potential markets where, for the scales that you spoke about, where it would be marketable? Or is it just purely meant for the rural market because of the need for agro waste? And will this work on any other kind of input, raw material?
Okay, they are not raw material agnostic. Any other raw material have to be studied and taken up. So I am not. So I'm neither dismissing the possibility of using other materials, nor am I confirming it. Pre-processing is something which might change typically. Food waste has certain issues and need to be taken care of. Typically, they generate a lot of scum. Food waste generates a lot of scum.
It's where I was coming from actually. So when you talk of, let's say, kitchen waste, so would it be?
So you see, it's designed for community scale. In urban areas, you typically don't have.
Like in Mumbai, right?
You don't have enough space in Bombay.
200 flats.
We don't have the kind of, if you saw the photograph of the size of the plants, our system is designed in areas where real estate should not come at a premium. In fact, we have consciously taken decisions, engineering decisions, where we have kept the area required as the variable, right? So even if it takes me less power and 100 square feet of area more, 100 square feet is a hyperbolic word, but say 2-3 square feet or 10 square feet more, and it takes me 100 watts less, I'll give it that extra area, because area is not a premium in the locations which we operate. But in
Can you some kind of scale, what kind of area you're speaking about in terms?
we set up plants between 100 meter cube per day to 400 meter cube per day. 100 meter cube per day.
100 cubic meter per day is a bio CNG generation?
No, raw biogas. All numbers I spoke till now in meter cube, standard normal meter cube of raw biogas. And this would need around 100 meter cube would need around 5 tons of animal waste, or the same plant can generate 400 meter cube if I add in the agro waste in different ratios. So I'll speak about one size only, and that size would be I would put half an acre. Half an acre is a little bit too much. That also has our auxiliary areas. We want go down storage, plant storage, etc. So the actual plant is much smaller, but if you add everything else, half an acre is something that we would need for 100 meter, for 100 to 400 meter cube plant, depending upon the feed. So we would need. We need an area for office, for our storage. For
100
machinery.
400 meter could be one
Same
meter
size? No,
size,
not
or
exactly
it
the
could
same
be
size. Not exactly the same size. As I said, the same plant, 100 meter cube to 300 meter cube could be the same size, because 5 tons of pure animal waste will give you 100 meter cube, but 1 ton of animal waste and 4 tons of agro waste will give you close to 300 plus meter cube. So it is the same size plant, but then we have a waste processing area, so that needs a little bit more area, plus and minus here and there. So if I am given a choice, I'll go for 1 acre, because land is not at a premium. As I said, it allows a certain leeway in designing the plant. So I think you would appreciate, given a half a acre more is always preferable. So since it will not really cost as a bomb, it doesn't cost. I mean, it's not Bombay where you optimize every square feet. Big deal. It doesn't affect the plant economics in any way. That would be probably, I'm talking 20,000 per year every year more. 20,000 per year every year more in the scale of the plant is nothing.
And typically, what is the capex and opex cost for this size of plant? Typically, are you 100 to 300?
300.
I'm sorry, I'm not authorized to speak on this as of yet.
Okay, fine. No issues. Absolutely fine.
So your product is in a different space really compared to the packaged sort of treatment plants, which are installed in societies for handling kitchen waste.
They are designed, they have an urban market in their purview, and we focus on the rural market. So their space is a premium in those plants. Typically, you have um, you would have a container being changed to do it everything on a vertical scale. We expand.
More of vermicomposting rather than actual generation of.
No, 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 no. No, no. There are companies who make biogas even for urban areas, and they are very vertically, they have very small footprints. They design for small areas. Space is a constraint. For us, space is not a constraint. In fact, the digesters which we use are, if you compare them to a Deenbandhu model is much more space efficient than the digesters which we use. But we love them because they have some very standard advantages in terms of being flexibility, weight. If it comes down to it, we will move from location A to location B at very much less cost than any other competition. It's a plug flow design. It's a design. If you can read about plug flow digesters, I think this might not be an appropriate platform to go into details, but it relies on movement of this dung over a long horizontal tube. So it's a long horizontal tube. In a sense, it's a long horizontal tube.
What's the lifespan? What's the design life?
Design lifetime is 20 years. Design life is 20 years. They're warranted for 15 years. So they expect, actually the design life is what they say. We believe it could be higher depending upon how we treat them.
So, typically in the projects that we completed as obstacles, so hazard analysis, what happens if this component fails, what happens if that one. So what can go wrong in a plant?
Everything can go wrong in a plant like this.
As in,
The only thing that we try to see.
From a safety perspective.
from a safety.
Yeah, the only thing. Yeah, the only thing that we. Fair enough. In fact, I was about to say that the only thing that we spend our time on as of now is what is that can go wrong, that can physically harm or kill somebody. We actually don't care about 1 day of downtime or 2 days of downtime. Those plants are not so valuable that we will spend a 5 lakh rupee component on ensuring that 2 days of downtime not occur, right? So what we do to ensure that nobody dies, or rather nobody is injured, is there are some standard areas which are restricted. But I'll tell you what is the most dangerous thing in this. There are 3 parts. One is the storage. Second is the scrubber, which can go really hot. The third one is the pressure, right? Pressure we have, as of now, we operate at atmospheric.
Pressure within the scrubber itself.
No, not within the scrubber, in the system. in the system. So at some point we were operating at slightly higher pressure, but today we operate at atmospheric. So we live with it. Not a problem. Not that. So one of them have been taken care of recently. The second of those, the other two, the H2S scrubber typically is kept offline when people are not around. We don't keep it operating, and it's visually, it's very much in the open, right? It's at the center of the plant. You cannot miss it if something happens there. Basically, it is the one area where which can catch fire, and everything is wild. Everything is wild. So we don't expect explosions to occur because these materials are so weak. Any fire occurrence, they'll first turn up. Methane just goes up in the air. It cannot explode. So since we don't have cylinders, so we worked really hard to ensure that all the we need not worry too much about safety. So
The output is all going to be pressurized.
yeah, so that's okay. We have not actually reached that area. This pressurized cylinders are still in our lab.
So you mean you just sort of send it out? I mean,
No. I'll tell you. So the R&D which you saw, I mean, had you been in the afternoon session, you would have seen that we are going through multiple pivots all the time, and one of the pivot was moving to bio CNG from grid electricity or mini grid electricity. So till now we were making electricity from this biogas in distributed areas which did not have electricity. And very recently, we have pivoted to bio-CNG. The bio-CNG has been done at our pilot site only, and not at all the sites which we operate. We will soon roll it out to all the sites where we operate. And so we are waiting because there are a few things here and there which we want to further improvise, safety being one of them. So, so to answer your question, we have not done that analysis yet for pressurized cylinders because we are still on the,
so all the
on the
output
stage.
that you get from the plant, how does it reach the consumers or the customers?
There are two outputs as of now: gas and compost. Compost is processed, made. The gas is right now going in the form of electricity. So okay, I'll give you a little bit more. So as of now, we don't have direct customers who consume our electricity. We have microgrid operators as our customers, who in turn used to run diesel generators to supplement their solar power plants. So we supply to them. And because we really wanted to focus on our operations and not worry about metering and everything. So we are a B2B microgrid electricity seller. So we sell to,
The gas goes to the
it does go, I mean,
for cooking.
no, it doesn't go for cooking as of now. Even if it goes for cooking, it is sent in very small cases. It is sent in balloons and it's not piped. Gas is not.
Piping may not make sense in the rural environment, but pressurized, cylinders can definitely.
Yeah, that's what we intend to do now. Yeah, so if you have a feedback, I'm more than open. I'm listening. Please tell me.
I mean, I'm not a consumer, but if it can be like packaged, right?
Yeah, that's what we intend to do, right? I said, I mean, we'll convert it to do a bio CNG cylinder.
But your biocide is will not be consumed by domestic users, right?
Should
Only for
not be.
industrial purpose.
Should not be consumed. They will not find it economically viable.
Yeah, because the operational pressures for CNGs are pretty high. As I said, we need to step down the pressures to make it commercially viable for domestic consumption.
No. We will step down the pressure. That's not the problem. But domestic LPG is available.
The CNG cylinders that are used to make taxis.
Yeah.
What pressure is
200 bar. 200 bar. 200 to 220. 200 is the minimum normally.
but that's used readily in the automotive?
No, they reduce. I mean, it's sort of reduced on the way into the engine.
There's a reduction process there.
Yeah, must be there. What I'm trying to
Then
say
that's
is,
the reason why this can't be.
no, this, okay, here is the deal. I think I'm missing parts of it. See, this gas has to be taken to a certain BIS standard before it can be used in an automobile. It can be used for cooking and industrial purposes. Much below it reaches that exacting standards. We are on our way to BIS standards. We have already crossed our way for cooking and industrial standards. Cooking and industrial standards are those where it is safe and where it will not make you change your stove. So it is commercially viable. After that, if I maintain some other parameters below some certain levels, where the power and everything of the engine remains appreciable, we can always supply to.
So it has to be transported to nearby towns from the rural areas. you're saying it's still today, in today's environment, it's still not commercially viable for home.
Transportation is commercially viable. Okay, I'll take three questions one by one. Number one, domestic user buys domestic LPG at 25 rupees per kg. Why would they buy LPG at 40 rupees per kg, say, or 45 rupees per kg, when they can buy government LPG? Maybe there was a market some point in history, but definitely not there anymore.
Because of the subsidy.
Subsidy was always there because cylinders were not available. Today, cylinders are available if you're willing to buy. At some point in history, even if you wanted to buy and you lived in some rural area, cylinder was not available. Today, you can buy. If you're willing to pay, you will get a cylinder. But even then, if today people are not buying today, people were not willing to buy then as well. So domestic users are more than willing to sell it to them. We are in the HP startup program. HP might decide to subsidize our gas and give it to the domestic users. I don't know. We might end up doing that. That might be one of our biggest businesses, right? Our support network backing us, we would do that on a pure commercial basis. In fact, we expect them to back us and get this done. That's one of our business strategies about how would we like to take our product to the market. I would like to sell everything to HPCL and forget about it. But in case that is not feasible, then vehicle is a market, commercial cooking is a market, industrial usage is a market, and we can easily transport it over some distances. Over, as I said, 500 kilometers is not a big deal, where it can be used in any industry or any commercial cooking place where it would make sense, because we are 20%, 25% cheaper than commercial LPG. I think that sums it up. Yeah.
LPG also cost actually 45 rupees per kg.
Nahin.
Day before yesterday, I got one cylinder at 665, so 14.6 kg, right? One cylinder. It costs 45 rupees per kg.
चलो ठीक है, तो 45 पे you will buy LPG ना, you will not buy my gas. And we are slightly outdated with respect to probably domestic LPG rates, but we don't see a market there.
Or attractive.
It's not attractive enough. I mean, imagine you save 30%. You're a commercial entity. You're
More from the Go Green initiative.
Yeah.
if you're a kitchen, around 30% of your operational cost is gas, and on that I'm going to give you 30% saving. Now it becomes like, wow, let's talk, right? So it's not that much fun for a domestic user, but we are open to it. If it becomes feasible, we will be more than happy. But we are more interested in the impact which the plant creates in its locality
So what's the
by making it financially viable.
for the farmer? What is the direct benefit in the
We actually have a fireside chat, don't we?
literally?
Yeah.
Sorry about the poor attendance, but a lot of people have deadlines to meet before
No.
Christmas holidays
I'm enjoying.
start,
I'm enjoying.
So
I'm enjoying.
we couldn't get. I hope the afternoon session we had.
No, I'm having a good time. I'm having a good time, but I just felt like we are having a fireside chat. So I spoke it. Absolutely. That's good. That's good. I should probably grab a chair.
Yeah, you should.
Yeah, you
Actually.
should.
Anyways,
Yeah.
let's
I
start.
think
I'm
yes,
just kidding. I'm just kidding. Please, please, let's go ahead.
Why don't you give just for a chair? We can talk through the problem. So yeah, I think so. Probably we can continue a chat while we have our snacks. So for those who are online, thanks a lot for joining us. I hope we enjoyed this very educative session with Pradeep today. Hope to see you all in next lecture. Probably the next Genesis Tech Talk will be about PPP projects, and we'll have two partners from Deloitte actually presenting about that. So see you all next. Yeah, so that will be on 10 Jan, and I think you'll see notice from me on that too pretty soon. Thanks a lot. Goodbye.